Hello everyone, welcome to Spring Boot tutorial series by JR Academy and thanks for joining again. So this is tutorial 5, Fundamentals of Spring Boot, and in this tutorial we will look into some of the some of the fundamental concepts such as what is IoC Container, what is Dependency Injection, what exactly happens when we start our Spring Boot application, and what is the auto configuration feature of Spring Boot application. So in previous tutorials, we have seen how to create application and looked into Maven and POM.xml. If you didn't watch my last video, I recommend watching it. That will help you to understand more. So let's get started with this tutorial. What is IoC? So whatever you are seeing right now in a computing world, like frameworks and libraries and different techniques and design patterns, everything is an attempt to reduce complexity, and even currently huge amount of activity is happening, especially in open source world, and people are trying to develop alternatives of complex stuff, and they are coming up with amazing and creative ideas. So to deal with these changes and activities, we need to figure out some way to combine our work or to wire all the components so they can work together. And for that purpose, there are a number of frameworks are coming in picture, and Spring was one of them. So providing this general capability of assembling components from different layers, we often referred as a lightweight containers. And so our next question is, what is container? So in layman's term, container is something, or it is a place where we can put something in it, right? If we go one step ahead with this definition, we can say containers are something that provides an infrastructure needed by some components to live, right? So if we see this definition in Java and Spring world, we can imagine JVM as a container to run Java program, or Tomcat server is a container to run a servlet. So keep this information safe in your mind, and now let's look into what is IoC. But before IoC, we need to see what is the difference between using libraries and using frameworks. So consider in case of library, our program control flow will be handled by our main program or our main function. So basically every project have some starting point from where our code start working, right? And normally main function is that starting point, and whenever we start our program and after that main function needs something, it will call another code, and after finishing that task it will gain control back. So for example, consider this very basic command line application to calculate percentage by marks of the two subjects. So if we start this application, it is printing basically enter marks in mathematics. So I'm putting 80, and another one is enter marks in physics, and I'm putting 70. So your percentage is 75, and let's look into the code for this. So if you see here in a main function, it is printing first line, and then it needs to get value from command line. So main program is calling scanner, an external function, or consider it as a library, and once task is done, flow is coming back to our main code, and it is assigning and printing second line, and it is calling scanner again for the value. So after this, it needs to calculate percentage, and for percentage it needs to call another library or another function. So it is calling our percentage function and then again taking control back and printing the result. So the flow of the program is handled by main function, and it will end at some point, or you can put while loop, and it will keep running until some condition. So now let's look at the another case of framework, and in case of framework, a framework is doing most of the work, and whenever it needs some application specific business logic, it will call our code and then again control back, it will gain the control back. So what is happening here is we are giving full control to the framework, not to our main code, and we are attaching our code with our framework. So this is the inversion of control. So inversion of control is a principle in software engineering by which the control of object or a portion of our code is transferred to a container or a framework. So with IoC, framework gets capability to take control over our code, and it can use our code whenever it needs it. So whenever we use a framework, we need to add functionality in some application. We add our code with the framework, and in some point in time when framework needs our code, it will call our code and then again do other work. So so this is basically the inversion of control. And now you know what is a container, and now you know what is inversion of control. So I guess you know what is IoC containers. Yes, correct. It is a container that gives ability to have IoC feature. But in case of Spring, in case of this IoC container of Spring, these containers have so many other important and complex software principles and design patterns in it. So which is the out of the scope of this series, but along the way we will discuss few of them. And there are advantages of using this principle in coding, such as decoupling, modularization, and mocking. And we will look into each one of these in upcoming tutorial. So let's moving further. So in case of code, our container is nothing but an interface, we can say. And in Spring we have two type of containers. First one is core container, and inside core we have bin factory. And another container is J2EE container, and inside J2EE we have two containers, application context and configurable application context. So in Spring Boot we will have configurable application context. So there are functionality wise little bit difference in these three, but higher level concept is same. But IoC is a broad concept, and whenever we say a framework have inversion of control feature, according to me it is unfair to IoC, because the right question is which part of control our particular framework is inversion. Okay, so in case of Spring and Spring Boot we have inversion of control over dependency, and generally these three containers have three main ability. Uh, it can create an instance of simple POJOs. POJO is a plain old Java object, and it can create the object of that POJO. It can maintain the life cycle of those instances. So basically it can create and destroy the object. And another one is it is able to do dependency injection. So next question for us is, what is dependency injection? But before understanding what is dependency injection, let's have a look into what is dependency. So for example, if we are building a house and we need a door, so here house class house is using class door, and that's why we can say house is a dependent over door. So dependency is nothing but when class A uses class B, we can say class A have a dependency on class B. And dependency injection is getting this door for our house. So to get the door, there are a couple of ways to do that. We can build our own door in our house. So it is basically when we create object of house, at that time inside the house class we initiate the object of door with new keyword. But instead of using new keyword, we can push this object from outside. So we can buy this door from some supplier, right? And there are a couple of ways to do that. We can use a constructor based dependency, and we can use setter based dependencies. So constructor based dependency is what, when we start building our house at the very beginning, we buy the door. And setter based dependency is what, we can start building house but later we can set it by some method, right? So this is dependency injection. So let's have a look into demo so you get the better idea about it. So to show you dependency injection, I created a small project here, and in that project I have this hello world object which is dependent on this greeting object. So I created this function greet, and this greet function is basically calling greet message function of this greeting class and taking the value and just printing it. So here we use a new keyword to inject the dependency inside this hello world. Okay, so let's go to main class and see I have created the object of this hello world and I'm calling this greet. So if I run this, I can see message which is coming from here. So if I say good morning, it will print good morning here. So The problem with this approach is it is very tightly coupled. So imagine if you want to change that message from your main class. Okay, and in this condition you cannot. So what I'm going to do is, instead of using new keyword, I can use a constructor based approach, and every time I create hello world object, I can pass this greeting dynamically. Okay, so to use the constructor, I need to delete this first, and then I need to create a constructor. And as I promise, I'll show you the different shortcuts of Eclipse, and there is one shortcut to create this constructor is to go to source and then go here in the constructor using fields. So we are going to use a constructor using field because we have greetings here. If you want to create a constructor without field, you can go with the superclass, the second option here. So I'll go with the field, and here I have greetings, and if I do generate here, it will create the object, it will create the constructor of the hello world. If I save this and I go main, it is showing that this constructor is not valid anymore. So I need to pass greeting object here. So what I can do is I can create greeting here, greeting with, I can pass my message here, and let's say this is for good morning. I can say good morning, and I can pass this greet1 dynamically inside hello world. And let's say I want to reuse both the class again. So let me copy this and paste it here, and I'm going to change the name a little bit. I do greet2 hello world 2, and this will have 2. So what I did is I used the same class without changing much coding, and instead of good morning I can write good evening. So if I run this, it will print good morning in first case and good evening in second case. So what change here? So what we did is we use constructor based dependency, which help to decouple it a little bit, and there is no like hard dependency between greet and hello world anymore, and you can pass this greet object anytime at the time of the creation. Now let's see the example of setter method. So let's keep this constructor based dependency here, and let me create setter here. So another shortcut from Eclipse is for the creating setters and getters. You can go here in source. Again, you have option for generating getters and setters. You click here, and you have option to choose. So I choose greeting, and then I choose only setters because I need to create only setters, but you can create both also. So I'm gonna go with select setters and then generate. So it created the setters for this. So what is this? So this is the method that I can call runtime, and I can pass greeting dynamically in it. So let's say in this condition you create two different objects for hello world. Okay, so instead of this I can do one thing. I can create only one hello world, and I delete this, and here I can use same object, but before this I can call that setter method and inject this greet2 inside. Okay, so I use same object again, and I dynamically pass using setter method. I set the dependency dynamically with the setter method. If I go with this, it will print good morning and good evening. So the benefit of this is it created only one object, plus it is decoupled. You can change this anytime. You can use this setter method again and again, and you can change this dependency on that greeting method. So this is the two different way to inject the object from outside. You can go with constructor method, or you can go with setter method. But imagine you need to have a lot of dependencies to create something, and injecting each and every dependency manually is not efficient way. So we have an IoC container that can inject those dependencies for you, and basically it can call your constructor or the setter method of your class. So till now we have seen three main features of IoC container. It can create the object, and this object we call them Spring Beans. Second, it can manage the life cycle of the Pojo, and another next one is when one object needs another object, the container can inject them. So when container is creating beans, it needs some configuration about few things, such as which method you want to use. You want to use setter method or you want to use constructor method. Second one is if a container founds multiple instances of your dependency, then which one to inject. So to understand this, let's consider our house example again. So you need a door, you went to supplier, and now you have 100 options for door. You need to choose right one for you. So in the code, when multiple class implements some interface and you have dependency on that particular interface, so you need to tell container which class you want to inject. Another configuration that container needs is the scope. To understand the scope, let's take an example of our house again. So let's say you need 3 doors in your house. So you have two options. You can buy one door and you can reuse the same door again and again. And second option is to you buy 3 different doors. So second option is best for us in this kind of situation. But let's take an example of screwdriver. So you need a different screwdriver every time you want to put in some screws, or you can reuse the same screwdriver again and again. This kind of configuration we need to tell container that every time someone needs some objects, you need to create a new object of that pojo, or you can reuse the same pojo, same object. There are benefits of doing this at the memory level. So this kind of configuration we need, and in case of Spring, we have spring.xml file for this configuration. So IOC, when we start IOC container start reading that spring.xml file, and at the time of creation of each beans, it got the information about this configuration from that XML file. But in case of Spring, we don't have any XML based configuration. Instead, we're going to use Java class file for the configuration, and we have annotation based configuration. So what is annotation? It is a topic of another video, and I will create another video and put a link in the description. But for now, in layman's term, understand one thing: annotation is kind of tag, and with that tag you can tell something to JVM about that piece of code. So when JVM is reading our code, it will reach that particular point and it got some information about our code. In Spring Boot, we will use so many annotations along the way, and we will keep learning them. So now let's go to our code and look under the hood what is happening when we start our application, right? So if you see in our main class, we have something like Spring application dot run, and we are passing our main class inside that run method. So this run is a static method, and we are passing the name of our class with it, and it is returning configurable application context. So it is basically returning container. So this is the starting point for our IOC container, and all beans will go inside this container. After this point, main class is not going to do anything. So control of our program will be with container after this. So whenever container gets some request, for that request it needs our code, it will call our code, and we are giving main class to this container, and magic starts, right? So when container get this main class, it came across our annotation on the top. So annotation on the top is Spring Boot application Spring Boot application. So this annotation is a combination of 3 different annotations. First one is configuration. So this annotation is not specific to Spring Boot application, but is a part of Spring Framework now. And this annotation tag on the class is basically we are telling a container that this class can be used for the bin definition, can be used for the source of the bin definition. So container will go inside and look for functions that is annotated with @bin, because that bin is a definition of particular one bin. We will look this annotation in detail, but for now just consider this annotation is very useful to initialize some beans. The second annotation is @component scan, and this tells Spring Boot to look for other components or configuration and services in the specified path. So Spring Boot will scan your entire code and look for all the classes with special annotation. So if you have multiple classes with the configuration annotation, it will go each and every one of them and create beans out of it. And if you have another classes with different spatial annotations, it will create a beans of it, or it will behave a different way. So next annotation is enable auto configuration, And this is a Spring Boot annotation which enables application to add beans using class path definitions. Spring Boot will create automatically some beans and register them for us. For example, it will go in our class path, and if it sees Tomcat embedded.jar, it will create Tomcat embedded servlet container factory automatic. Same way, it is creating so many different objects and register them with us. So basically it is saving a lot of time in pages of configuration. Also, it set up some default behavior of the application which is applicable for 80% of the cases. You can make it more configurable by adding some XMLs or Java config classes, but most of the cases you don't need to do anything, just one annotation and all your application will work perfectly fine. So this is the one of the most important annotation in Spring Boot, and let's see a small example of it about default behavior of the application. So Spring Boot have its own default behavior, but we can change it based on our requirement. To show a demo of that, I'm going to change a very small thing in the Spring Boot's default behavior. So this is the banner that come with this is the default banner that is coming with the Spring. But if I want to change this, so what I'm going to do is this is Spring's default banner, and I'm going to change this. So to change this, I don't need to do anything much. So what I'm going to do is I'll go to online some banner generator, and I copy this, and let me change this so I'm gonna create this one. So I copy this and paste it inside this resource folder. So inside this resource folder, I'm gonna create one text file, and I'm gonna give a name banner.text. And if I create this, I need to paste that thing here and save it. And now if I restart this application, you will see the change. So see, it take this banner as our change banner. So this is the power of Spring Boot. If you provide something, then it will take that behavior. Otherwise, it will take its own default behavior. Same way, we can attach index.html file inside this static folder like this. And so what I did is I just put like a small HTML tag, and if I after starting this application, if I go in my browser and hit localhost here, and you can see it has this by default page. So for your application, you can provide its index.html. So if something is not there, then it will go its default page, and you can set up so this way you can change actually so many things, but this was like very small demo for that. So that's all for now, and this was amazing tutorial. See you in next tutorial, and till then, like, subscribe, and keep learning. Thank you very much.